morning. My name is Zdenek. I guess that's the reason why people call me Z. I have a hard time to pronounce it. I'm the Rockwell Automation. I am a services solution architect, so I'm from the services side of the Rockwell. And I'm based in Nashville and also covering this part of the area. And really the first, I may have on the end of my first 30 so minutes, I have a couple of slides. But I don't really want to go through much presentation at this point. Just kind of set the stage what we want to talk about today and what actually, what's the situation today is leading us to have a discussion like we have today. And I have a few numbers here, which I'm sure that will make sense right now. And I'll put some sense to it. Just kind of set the stage. What's the situation today on the market? And this is through some research groups. They're providing this data. So what do we know? That $65 billion of worth of automation equipment is obsolete. Install automation equipment is obsolete. The 88% of customers are aware they've been using obsolete components. Some of them a different approach, right? Some of them just know, yes, we have it. Some of them have a plan, and this is something we'd actually want to talk about farther out. 2/3 of harvested equipment. Harvested parts means they've been installed somewhere and people are trying to use them as spare parts, but 2/3 of those don't work. They fail. This is 29 years. That's what PLC5 is on the market. Which, I'm sure that everybody understands that in the pace where the technology goes today, there will not be another automation or electronic or any of those components on the market for that long. 2009, that's where the big economic downturn was in 2009, and a lot of manufacturers, they purged their inventory. Suppliers, they purged inventory of the slow-moving parts. And the slow-moving parts were majority of the components of being used on the old or obsolete equipment to repair or manufacture. So that changed dramatically in 2009. How all of a sudden the components they've been produced that are already available became obsolete very quickly. 10 to 5, it's for 10 retiring people, only 5 people are available to take their places working in the maintenance engineering. Only 5. And $20 billion, that's the estimated cost of the downtown related to all these above. So these are some pretty significant numbers, right? So I have a little help here. So let's just look at the scenario then, 20 years ago. So there was a piece of equipment, but usually standing alone, and the approach of maintaining that equipment was when it break, we fix it. That downtime and the effort associated with with repairing that equipment was manageable. Well, these days, the same equipment, it's actually more sophisticated. Integrated. But at the same time, as you see here, it's a mix of new and old. So the good news is that all this integration and sophistication and all that modern equipment today help to increase the productivity, by about 40% since those 20 years ago. But at the same time, any time and any component of that integrated system fails, there is a higher risk that the whole system fails. Therefore, the cost of the downtime is much higher. And because it's a mix and all new, that the risk is much higher from the obsolescence standpoint. So let's put this here as obsolescence risk associated with the downtime. And at the same time, while we have all this scenario, the number of people, the available parts, the number of people in a maintenance, or same like here, but also the companies are reducing staff when they can, or the people, knowledgeable people are not available. The companies have a strategy to reduce available spare parts, to reduce the carrying cost, to reduce the available inventory. Maintenance budgets, they are being reduced. I've been a victim. I was a maintenance planner for 10 years, and I saw that every year coming down, even our plant was growing. And the capital dollars, capital investments, are also being reduced and scrutinized, and everybody is turning that dollar 2-3 times before they actually spend it. So let's look at how they look in this scenario. So we have, this would be failure rate. This is the time. And this is the maintenance cost. So it does make sense that with the age of the equipment, the failure rate increases with the time, and then increases the maintenance cost gets higher because the equipment it's hard to find, it costs more, and affecting the maintenance budget. So if you look at the scenario here where, let's say this is production, and production is running with some variances, and all of a sudden we have a downtime. And the downtime, so we're trying to identify what happened, and we find out that the downtime was on the old equipment, old drive, which is obsolete. Because the guy who knows that equipment, he'll retire, go in the scrambling mode and try and do some trial and error or try to fix it. And we have the time going, right? We identify what part we need, and then we find out that whatever we had available was removed from the old line or was bought on eBay, or local distributor don't have it because it's long obsolete. And we find out that the part failed. So we need to find a part. Downtime continues. same time, because the guy who used to program the drive is no longer with the company, he's looking for somebody who can actually work on that equipment, who can replace it, program and get it back running. And there are a lot of things associated with like POs. We don't know how much they're gonna cost, and it's a lot of red tape, and everybody's still asking, hey, what are we gonna be back up? So eventually, everything goes back up because good guys in IAC, they searched around the globe and they found a replacement part. They found a replacement part, and we can continue here. But all this scenario has actually increased the downtime cost as well. So we can follow that. So if you look at it from perspective of the electronic equipment, there is the curve of the life cycle of electronic equipment. I don't know if you ever seen it. It's the bottom curve. So this is when we can expect some infant mortality. The electronic equipment, usually if it fails very soon. But if the establishment is running, there is a normal life of that equipment. But as it's getting older, the possibility of failure increases. So this would be the end of life. So all this has a big impact. All the parts, they're being obsolete and no longer available. We don't have enough people know to work on the equipment. The parts is hard to find. The budget and capital investment to migrate, they are being scrutinized. Plus, we have long, install base of the equipment, which is running out of life, and the failure possibility increases. So what we really want to talk about today is how, under all these circumstances, what we can do to work together to change that, let's say, in your facilities. Because I'm sure you face some of those aspects of this at your daily job. So the goal really is to identify the risk. So really identify where my risk is and what level of risk is related to the equipment, its age, parts availability, and also criticality of the equipment that those parts are installed on. Then have a plan to mitigate that risk short term, to find out if I identify the risk, what I'm going to do the short term to mitigate this risk associated with the obsolete equipment, while I'm working on a long-term plan to eliminate the risk altogether. And that's something what really we want to talk about today. What are our capabilities and how we can make sure that we help our customers. They are facing this situation with really get ahead of the curve, and with identifying the risk, even how tools and processes and how to mitigate the risk and ultimately eliminate, and just keep that life cycle, keep ahead of the curve of the life cycle of the equipment. Because as we know, this is not going to get any better. Notice this. that always will be scrutinized, and people not available. Same thing with the parks, reducing the stores, reducing maintenance budget, and scrutinizing capital investments. So that would be, does that make sense?
Sounds just like our factory.
I guess, and we see that every day when we go and have these discussions. It's basically, this is the big picture, and various customers are facing various challenges, but based on similar facts.
I think what we have to overcome is, I think everybody understands we have aging equipment, we have rapidly moving technology, and we have less money and less people. I think the magic is what I've seen work is we have to take a machine or a line and say, okay, here's what's installed in that machine. You have no spares. We have no spares. If it hits the fan, what's the impact of this machine on the plant? Oh, well, we're hosed. Okay, let's quantify that. And you go to the man with the checkbook in the plant and say, here's the level of risk on line 1. Here are the facts. And if you can't throw money at it immediately, at least you can have a plan to throw money at it later while you manage that risk. And I think that systematic approach is the only thing that gets their bean counters in there, are they? It's the only thing that gets the bean counters' attention.
Well, that's a big change, though. We've gone from actual business people running companies to bean counters running companies.
I understand.
And equipment was originally bought with automation equipment installed as a line item.
It is.
Instead of a separate asset. So now the equipment may still have age, but the automation portion doesn't. And now you can't split it up because the bean counter doesn't see it that way. And so now you're trying to justify a capital expense, but you're not justifying the cost over the life of the machine, so they're not getting their tax write-off. So they're not going to do it. Now the plant comes back to the plant as an expense item. Now the plant has to eat it, even though it requires productivity of the plant.
Yeah.
Upgrade it.
Well, we all make stuff, right? We make stuff and ship it out the back door. So what I found that really, I can get the ear of a production guy.
Right.
And then guess what the plant manager, who he's talking to, how many widgets are we going to ship out next week, right? Production guy says, not really. We're at high risk because we have downtime on line 1, right? I found that the plant manager or the checkbook guy is really paying close attention to the production people, not necessarily engineering or maintenance or quality, right? It's about the production. But anyway, I just think it's interesting because inevitably when I paint that picture to somebody and say, man, PLC 5s, you're in trouble, whatnot, and they can't get the money for it, 6 months later, why didn't IAC have any 580Es on the shelf?
I fight that daily because we're trying to upgrade one line. Well, the whole line was bought, as a line item. Here's what we paid for the line item, $1.2 million.
Yeah.
And then you go, okay, well, $100,000 to upgrade the PLC system. Well, that's not 20% of the project. So we can't go, it's no longer a capital expense on the plant, it's a spend. You go, wait a minute, it's a $100,000 project.
Yeah.
Just upgrade, 4 racks.
Just 92 of it was ours.
And it's hard. It's hard for people like you to understand that, to really justify. And usually, in many cases, it's event-driven, right? Then all of a sudden something goes down. It's hard to come back and say, "I told you so." We don't have it. Now we have to migrate. Now we have expediting parts and have a large cost with with migrating on the run. And we have a lot of ways and a lot of tools how to actually help people like you to justify, to really get the whole picture, put some numbers on it, see the put the risk in the numbers and put the return on investment in the numbers. Why do I need to migrate? Why is it a good decision for me to migrate today and not to wait till tomorrow?
You should put the money cost in front of them, they see that.
Yeah.
But then you try to get a CR pass through the corporate, they're going back, it doesn't match the asset. Well, we need to be smarter about how we justify capital assets, I guess, and actually break those control systems out to actually be capital projects.
Yeah.
And that's what I'm seeing, because they're looking at, we bought all this equipment together, and Now you want to change it, you're not changing all of it, you're not changing 20% of the value of the asset. So now, we're not going to need the capital money to do it. So now we have to go back and say, okay, this part of this piece of equipment is a capital project for the next time. You know, so if I'm going to build a new line, this is my control system. This is how much I spent on it. So 7 years down the road, when it's time to replace this thing again, I'm going to go say, this is money I spent on this. And this is my line. I'm going to replace this again.
Yeah.
So.
Well, most of us have heard through our career, if it ain't broke, don't fix it.
I was just thinking that.
And that used to drive me nuts, because I'm a maintenance guy. My job is to work on fix it. But eventually, we got to, if it's broke, fix it. And so that meant finding the weak link and replacing that, you know. And so if you're going through a lot of input modules, find out what's causing that input module to go out and upgrade that or whatever. If you're losing a lot of processors, because the PLC5, if you're losing input and output modules on a PLC5, that swing arm is falling apart. It's disintegrating, it's coming loose, and there's a lot of things like that. So it's about time to go ahead and upgrade. And if you're going from an older processor to another one, that you are going to increase productivity, reduce downtime, and get more information back to the bean counters that they can get something out of it, and it's worth it. But I cringe every time I heard that they broke, don't fix it.
I've been in the same situation when I was trying to get the finance project. It's no big project, right? But there is obsolete, there was mechanical error some parts. So it will cost us because we cannot find it. There is nothing fit that measurement. You know, if we were going to do it in a downtime and we'll spend this $80,000, then we'll be in trouble. Didn't get the money for it. But when they pumped them down and didn't have the parts, we had $150,000 what it was cost to really scramble and do the project on the run. And you know, and that was not counting downtime. So that's, like you said, you know, it's that approach is there, but it's hard to change it. But I see that many people, many companies are start thinking that way. They have to have some kind of proof, some kind of, you know, show me, you know, what is the risk, what the risk associated in the dollars, and how I can compare it if I will try to eliminate the risk, what's my return on investment on that.
And a lot of times these migrations, they don't need bean counters. They just need the guys on the floor in the middle of the night upgrading. So take that opportunity and just do it.
Exactly. So really, the goal is to, you know, help you to make an awareness of the automation obsolescence and develop strategy to mitigate and ultimately eliminate the risk. And these are those three elements. And I will end it with this. And when I go back at 10:15, I will kind of come back to this and really show some from a services perspective how we can assist to address these three things. So thank you, Jim.